Hi everyone, I am Bindeshwar from Post Network Academy, and in this video you will know about limit and derivative of a function. So let's get started. Consider a function f(x) is equal to 5x. Now to explain you limit, I will make a table where I will take the value of x and I will see the corresponding value of fx. So here x and fx. Now if I put value of x is 1.6, so fx would be 8.0. If I take value of x as 1.7, so value of fx would be 8.5. Now again if I take value of 1.8, so fx would be 9.0. If I take again 1.9, so value of fx would be 9.5. And if I take 1.98, so value would be 9.9. So see that here you can observe that when x is approaching to 2, then fx is approaching to 10, and this can be written as when limit x is tending to 2, fx value is 10, or limit of fx is 10 when x tends to 2. Now in general you can write that limit of function fx is L when x tends to a. So this is the definition of limit of a function, where L is limit of fx. See that here, f value is tending to basically 10 when x tending to 2. So here x is not equal to 2, but x is approaching 2. Then fx is approaching 10. So this is the definition of limit. Based on this definition, I am going to explain derivative of a function. So let's see that. So if you see a function, the same function fx is real valued function, the function defined by limit, I have written the whole one, h tends to 0, that means h is very small, f x plus h minus f x upon x plus h minus x, wherever limit exists. That means limit of the function should exist. Is defined as derivative of fx at point x and denoted by f dash x or d fx upon dx. It is also denoted as d, and also y dash, and many more notations. So finally you can say that f dash x, that means derivative of f is denoted by f dash x is equal to limit h tends to 0 f x plus h minus f x upon x plus h minus x. So here x and x would get cancelled. So finally you will write limit h tends to 0 f x plus h minus fx upon h. So this is the derivative of fx at point x. Now to understand it, let us take an example. So we will see the derivative of fx is equal to x square. So see that here solution. As you know that derivative of fx at point x is defined as f dash x is equal to limit h tends to 0 f x plus h minus fx upon h. So here see that we have fx which is x square, and f x plus h would be x plus h whole square. Now put these two values in this equation. We will get f dash x is equal to limit h tends to 0 f, here limit h tends to 0. Here I will put the values of f x plus h as x plus h whole square minus fx, so that is x square upon h. Now it will become x square plus h square plus 2h x minus x square h, and of course limit h tends to 0. Now let us see that again. F dash x is equal to x square plus h square plus 2hx minus x square upon h, and of course limit h tends to 0. Now x square and x square will get cancelled, and what will happen? Limit h tends to 0. Here I can take common h, therefore h plus 2x upon h. H and h will get cancelled. Thereafter f dash x is equal to limit h tends to 0 h plus 2x. Again that would be equal to 0 plus 2x, and that is equal to 2x. So derivative of fx would be 2x. So in this video we have learnt about limit and derivative of a function.